All right. We're coming back. Let me lower the audio a smidge. All right. Welcome back. I'm back. I've been away for a little while, but it's good to see you again. Hope the world hasn't been too busy or too hard on you. And yeah, let's get down to some Haskell hacking. So last time I did a stream, we made a snake using SDL2, which was fun. I kind of want to wrap up this project as much as possible, which is the interactive fiction engine we've been working on for several months, most of this year, and just kind of get that done. So, in that vein, last time we worked on this project, I believe we were working on the author tooling. So I'm gonna just set my project up to start building with the file watcher. We're going to do that. So we're working on, I think, a parser, because we just kind of wanted to simplify the input file format that the user actually writes their game data in. So like the room descriptions and all that stuff. And have a CLI tool that kind of just packages all the game assets together, turns it all into the proper JSON formats and everything, and then creates a zip file. And that's what you hand to your users, who then run the game engine proper thing. I don't know exactly how we'll get the engine itself to like load different game zip files, but that could be a version 2.0 kind of thing. As long as it's in the right path for now, I think that'll be good enough. For a very, very minimum kind of project. Because I got to remind myself, this is a kind of just a learning project, so let's not get too carried away with it. But maybe, who knows, maybe it'll become an actual thing. Maybe people really like this engine. Whatever. Let's get to it, shall we? Where am I here? I'm over here. Adventure, we were in the maker. Maker's our thing. We're working on the parser. So what do we have? We got the line parser, room parser, section, room section parser. And the data, the test file I'm kind of working with, world.txt, say. Yes. So I had this idea of kind of following maybe like this section, almost like an INI style type thing where you have like different sections for different types of data that we're going to parse out of here. So the idea, I guess the idea would be like the front porch and then like a marker. And then we can start a new room. Let's fire up the REPL here. And in the REPL, we should have like room parser. Yeah, okay, so that's in scope, that's good. And the other thing was learning megaparsec. Let me pull up the documentation for that. So running a megaparsec parser. Parse test. Cool. Do we have parse test in scope? I do. Super. So we should be able to run parse test. Or we can load up our file. With read file. And data example adventure world.txt. There's that. And then we should be able to parse test. Is it the parsec parser? So let's do room section parser we're working on. with that. See if that works yet. Good match type string with text. So turn on overloaded strings. Well, it really wants it to be, what's the type of W string? It really wants it to be a text. Okay. So let's do this. Yeah, so something's going on with my audio here. Ah, there we go. Perfect. Okay. Yeah, so I really wanted to be to text, so let's rebind W and just, can I just make that a text? No, it's not in scope. Okay, fine. Let's import data.text.io st, qualified st. Qualified. I'll do W. Mistype something? There we go. Now W should be a text. And then that should work with our parse tests. There we go. Okay. So it looks like that does kind of work. We can get a list of rooms from our section. And, well, the user can't define everything that they can define in a room in this file format yet. But we're just getting started here, so that's pretty good. So this world.txt is trying to mimic whatever we're trying to output a world.json. So now we can fill in a list of rooms at least. The world.json also needs a list of objects, the list of exits, the current player room, which basically the starting room, the verbs that are available to the player, and the inventory. So for a minimal kind of like, let's just get this tool kind of working-ish. We could probably add, this is probably enough to add a CLI front end to this and start making like the actual application that we can use from the command line to parse this file and generate not a full world.json, but start populating it. So let's look for a Haskell CLI library we could use to make that a little bit easier. There are like raw APIs available in Haskell for like working with command line arguments, like you'd probably expect in most languages these days, or at least most full-featured languages, general purpose ones. And that's in base. So I'm just going to kind of go there just to kind of show you. In system, system.environment and friends. So you can get a list, get args, returns a list of the program's command line arguments, but it doesn't parse anything. It's just a list of strings, right? Depending on your needs, that might be sufficient if you're just writing something really, really simple and small. And maybe that's what we should start with. Why not? All right. If we just import it here. system.io and get args. Should be there. What is there? What's in scope? Contents, line, offset, source position, parser state, all that stuff. Oh, system.environment. I reported the wrong thing. That's why. Beep. System.environment. Okay, now get args. Right, we should have an empty array because we didn't really call this off a command line, so that makes sense. Okay, so why don't we go over to the kind of like main entry point for this maker, or let's create one. Source maker, what do we call it, like maker? No. Yeah, we'll call it maker.hs. So this will be where our entry point will be. We'll have to import system.environment. And let's see. We'll call it run. And we'll just do args, get args, put stir len, show args. We could just probably print args is what it's going to tell me. So let's just do that. Print args. Bang. And exec. Oh, I'm in the wrong directory, of course. So we have something hard-coded there. Let's go to app and the main entry point there. We can import maker. And we'll run. Oh, no, sorry. That was wrong. Wrong app. It's an adventure dash maker. There we go. Okay. There we go. That's a little better. There we go. So if we put SDF like that, we get SDF like that. You know, and you might kind of look like that, but in order to kind of escape that, you have to do with a double dash, and then you can get psh. Okay. And the reason why you have to escape that with a double dash is because of like shell parsing and all that sort of stuff, right? So we just get strings here. What do we need for Adventure Maker as its parameter, as a program, and how to use it, and that kind of stuff is what you get with command line processing frameworks. Usually you get like some kind of help text or usage text that you can set up, and you get parsing of like arguments and how they're handled, parsing of their types and like kind of that stuff. I think the simplest thing we can do here is if you give us no arguments, i.e. the empty list, we can print out some help text about how to use our program. And otherwise, we just have one argument really, which could be just the directory name of where to get all the your data files that we need to parse and turn into a zip. And that's it. So nothing too complicated there. Okay, so if we go args and get args, which comes from system.environment, actually, before we get into that, let's leave a run there and checkpoint. We'll add maker. That's all the data files we don't need to add to the source tree yet. Or maybe not at all. And we'll do that. We'll stage this. Add run entry point to maker. Okay. So we could do that in maker.hs actually, which is what we're doing here. Okay. Get args, print args. Okay. So when we have args, we just need to case match. We have two cases where we have one argument or more, or no arguments or more. And we only really care about 0 or 1. So we can case match on args. And say, if we have, we can say exactly 1. Path. We do something with that. Otherwise, we would just print the help text. All right, what is help text? We have to define that. Usage, adventure dash maker, VR. And then kind of just give a little string to help the user know what to do on the command line. Of course, if we are really shipping something here, like we should make proper documentation and all that sort of stuff. But we're just starting out small, so let's just start. Let's just do small. What's the problem with this? We just have a hole here, which is fine. Okay, so now we have to use path and do something with it. We'll call it process path. We'll pass the path to it. Let's define that now. Process path. Takes a file path, does some kind of I/O action. That should compile and be good enough there. We still have the undefined, so we have to define what process path actually does. Okay, so it's going to, we first know that we need to look for a particular file, a world.txt file. All right, so we're going to need the file path stuff to construct that. That comes from I think it's in base. We've used it a little bit in the engine. Where is it? File path. Or maybe it's in the library. I can't remember. Are we using system.filepath? It's been a while. Yeah, we are. Okay. I'm fine. That's all good. Import system.filepath. Which is probably a good thing to do anyway. Just so we're cross-platform. So we can do path. And I believe the operator looks like that. We can do world.text. It should be world text. We're going to need, so we got to do something with world text. Obviously, we're going to parse that file. So we're going to need our parser. And currently, all we can parse out of the world text right now is the rooms. So we're going to have to modify this as we go. We could write this from a top level kind of way where we pretend we write this parser that does everything. Parses the world JSON, the world data, whatever that happens to be, with megaparsec. We could use parse maybe. Run parser is probably more what we want. So we have an error, a useful error message. See, the file is only used in error messages, maybe empty string. Well, we don't have to do that. So we can run, we're going to need parsec for this. Import text.megaparsec. Run parser, world text is the file path. Or world text path. Let's say we're going to refer to it twice. Let's bind it. That. And then we can get rid of this. World text path like this. And world text path as the error message to run parser. And the parser we want to run is parse world. And then we have to define that in here. So let's do parse world. Or we could call it world parser. I don't know the structure exactly what it's going to return yet. Hang on. We'll get to that in a second. World parser. And leave it undefined for a moment, just to get us back to compiling here. So we have the type, just the type hole. Cool. Yeah, so world data is going to have to return our world parser. It's going to have to return a world. I think. Go adventure engine. Is it objects? No, that's a database maybe? No. Maybe it is in engine. Okay, it's an engine. This is ultimately what we're serializing and deserializing. So this is ultimately what we need to produce. So we can put that type there. And we need that in scope. Okay, and if it's successful at that, then we should be able to use that world data to write out a world.json file into some output path. Which, should that be the, do we need a parameter for that in our command line, or should we just put it locally, like as a relative path to wherever the command is run from? Into your current directory. Could probably do that for now. It seems kind of meh, but it'll be easy. So let's go say output path. Or we can just put in the output, the path we get as input too. Output path game dot, or no, the output path should be out or build. Okay, so for now, let's just write out the world data, world.json file to that output path. And to do that, we just have write file. We want output path with world.json. And what to output. Oh, right. Run parser returns an either. And we have to pack that as text. Or we can use import text dot qualified data dot text dot io as t. And then read file we should replace with t.read file. Did I get the type of run parser messed up? Oh yeah, okay, so we're supposed to give the parser first. I just got the arguments in the wrong position. World parser. And string is the name of the source file, and S is the input. Yeah, there we go. Okay. And then for JSON, actually data.ason I think has the IO action we need. Encode file. So let's do that. Let's use in data.ason. And we'll do json.encode file, the world path, the output path, combined with the world.json and the world data. And our error here. Right, so that's only if we can actually parse this. We have to case match on world data. It's on the error thing, and right, we have world data. So we don't want to, it's world data result. Okay, so in the error case, then we have error bound, a parse error bundle. Megaparsec might have a way of just showing that to the user in a nice, helpful, friendly way. What is that way? Error bundle pretty. Mm-hmm. Okay. So then we just pass that to putsterlen. Okay, cool. So a very minimal program here. Where we can give it our input directory. We hit undefined because we haven't defined that parser yet, but there we go. That means we're actually going into the code path. Pattern match, which is fine. So let's go implement that parser now. So all we can do right now is get the rooms. And return a world object of some kind. Where world rooms is that. And yada, yada, yada. So let's bring that up. World objects can be empty. World exits, empty. World player room. We can just whatever there for now. Player inventory. Empty. World player verbs. Empty. And world player messages. Also empty. Just a little typo there. There we go. Right, so this is the part where when we parse the rooms out of the sections, now we need some way of generating IDs for our database that are unique. So that's basically what this error here is like. This is supposed to be a map with entity IDs for the rooms, but we don't have any entity IDs. We're not generating those yet. We're just parsing the list of rooms. So this makes things a little bit trickier, but not something we can't overcome. The tricky thing is I don't think there's anything too tricky about this. The entity IDs are unique to each map. What's going to be tricky about this though is in parsing the format. So if I want, the room has to reference exits, for example, which are a related kind of concept, right? So like connecting the front porch to the main hall happens by exits. And in order to refer to those things in the source text, we need some unique identifier, right? We could say to the user that, yeah, you just have to use unique names, or we could tell the user that they have to create their own identifiers and like type them in. So I'd have like, say 2 dot the main hall, 1 dot, or we can just imply implicitly that we could fill this in for the user implicitly and say the first room we parse is going to be ID 0. The second room we parse is going to be ID 2. And we could follow that convention through the rest of the files for like exits. If you want to refer to whatever exit you define in the file by index. And that might get a little bit tricky to do if you have a really large file to edit. So what the best approach here is, I like explicit over implicit. So maybe what we should do is require in parsing the room that the user do like number their own rooms instead of doing implicitly, so that it's there in the source text when they want to refer to it, right? Because I can imagine if you had like 50 different rooms, right? And you have to be like, what room is it that I need to refer to, or 50 different exits that I'm referring to, which one is number 49, or I don't know, 32, somewhere in the middle is going to be the hard one, right? So you have to like go through each definition and be like 0, 1, 2. If you're searching exit, you go to the exit section and then you can search for the number, then it's pretty unambiguous. We would just have to, in the parser, detect if the user enters like duplicate room IDs. Like that would be a parse error. I like that approach better. Yeah, let's do it that way. However, we need to make this work now with the least amount of change. So if we go back to parser, let us just get it to compile where we just use the implicit index, and in a separate change, we'll make the index explicit. So we're going to need m.fromList, and we'll take that to be the zip of rooms, and I like zero-based indexing. It might not make sense to non-programmers, but we'll see. It should probably be the other way around, shouldn't it? Qualified data.map as m. Right, so actually, it's not technically integers. It is an entity ID, so we have to map those. We could do that. With list comprehension. And fix this type error. This is redundant. Cool. Okay. That, I believe, compiles. Yep. And so that's a runtime exception. Open binary file does not exist for writing. So we have to ensure that the directory exists before we try to do that. Okay, so we need some kind of action that ensures output path exists. Maybe file path has something in it. Or maybe there's already one built in the base. No, it's got to be, what am I looking for? System.directory, of course. Create directory, if missing. Create as parents too. Sure. There we go. And if all went to plan, example adventure world.json output build world.json should exist. There we go. Wonderful. Okay, let's commit that. Nothing else really to, so there we go. Add world parser to Adventure Maker. Yeah, not the best commit message. Added process path, which takes the first argument to the program from the command line to be the directory, base directory. We read files, read input, and generate the game.zip. This change implements the minimal parser to generate the world.json file that will ultimately be added to the game.zip. Cool. What do we do next? Well, the next most minimal thing, we ultimately want to generate a zip file, so let's just add the game.zip or game.json, the world.json file to the game.zip. And output a game.zip file as our output rather than this world.json file. So for that, we're going to need our handy dandy zip file library that we've been using with, say, the Adventure Engine to root, but instead of reading zip files now, we're going to write them. So, yeah, let's do that. Codec archive.zip. So we're going to create archive. It takes a file path, actions that create the archive's content, and an MA, something that implements monad.io, which we are going to be in. Okay. Create archive seems to be what we want. Oh wait, we have a couple of things. First, we wanted to, before we get to that, sorry, I should be writing this down in my to-do file here. We wanted to do the parser. I wanted to change the room parser for the explicit IDs. Before I forget. Update room parser to take explicit, to parse explicit room entity IDs. Currently, we're going to be working, I want to do that one, yes. We should also enter in the generate game.zip from Adventure Maker. Okay. Yes. So while I'm on that game.zip train of thought, let's just do that quickly because it'll be, I think, hopefully pretty straightforward, and then we'll do the parser. Create archive. Some arguments. It's data codec.archive.zip. I think actually it's going to go up here. And just import it as Z. Actually, I'm just going to import it. I don't think it'll overlap with anything. Yeah, create archive. File path. That's going to be the output path with game.zip as the file. Okay. So create archive, and then we can add entry. Contents. Name of the entry to add. So we actually need to encode to a string now instead of to a file. Unless there's a path to the file to add. We could do load entry like that. World JSON path. World.json. Load entry. We're going to world.json, and it'll be at world JSON path. Codec. Oh, entry selector. Okay, we need to use muck entry selector. Okay. And that is some m. So we can just do that here. As JSON entry. Selector. Like that. Problem with this is no. Okay, entry selector. That's fine. That should take a file path. Hmm. Oh, so I'm missing an argument. Dear, compression method. That's what the problem is. Deflate Z standard algorithm. I don't know which one's best. Okay, that's better. Sorry, that was a bit of a brain fart there. Okay. So now if we run that, we should get this. And if we look at data, example adventure, build, there should be a game.zip file there. Sweet. And if we cd over to that and just rm the world.json file we generated from before, we unzip game.zip. Okay, that's probably why we just want to use like deflate or something, I guess. So let's jump back to where we were. Run that again. Come back again. Now we unzip it. Yeah, so we unzip the world.json file there. Super. And so that's done. So this change when applied will add zip generation to Adventure Maker. Process command, the processor will now generate a game.zip. It's not fully compatible yet. But it's there. Just gonna revert that zip generation. There we go. Okay. Let's mark that off. Let's do the room parser. Let's get back to that. Okay, so changing the room parser, we're going to still parse a single pound as our kind of our beginning character. A space. We'll take the room ID to be a number, digit, integer. Gonna be like a megaparsec number parser. This usually most libraries provide that. Common parsers. Not all, but you know, it's pretty common to have them. Source. No, not source. I meant contents. Car. So we have digit car. Okay, well, maybe it doesn't have an integer character, but we can write one. Or we can write a ID parser. Entity ID parser, that'd be better. And we'll have to give a value for its phantom type parameter, I think. So if we look at database, entity IDA, the phantom type parameter here, to construct it. I don't know how we could do that. I would like to be able to do it like this. And let's see if GHC can tell me what the type of that should be. I did mean to enable type applications. I can't quite do it. Okay, so what did that look like? Parser of entity ID of a. I guess that kind of adds the implicit. There's always kind of like this implicit for all a here. So even though we don't use a as a parameter, we still pass it in. That should work. So in order to parse an entity ID, we're going to take all the digit characters up until we reach a period, say. Or maybe we should use some different punctuation to denote them. just in case you want to be able to use them inline in something else. Let's just stick with the. If we run into parsing problems with it, we'll change it later. Let's just stick with the digits dot. So that will be many till. We'll do t.pack. Digit car, and then period. Or just car. I'll have to do car, I guess. Single, sorry, single. Single dot. And then we have to interpret that as a Haskell number or integer. Might be able to do it like this. We have entity ID of read digits. So we don't want to pack that. Not necessarily safe. Potentially, but it should be because the parser is only going to parse digit characters. Okay. Then room ID isn't used anywhere, so that's a problem. So we got to change the value of room parser to be, we'll make it a tuple, I guess. The entity ID of room and the room. Room ID. And we'll let room equal that. Get rid of that. I'll pull this over to the, yeah, it doesn't make much of a difference. Okay, now section parsers have a problem. So parser list of room. Entity ID of room. And that's fine. And now we just need m.from list. Okay, so now let's update our world.text. So now this should be able to parse like 1 dot, 2 dots. It's not quite correct yet because we have one more requirement that we need to fulfill. However, this should be good enough. So let's go over to the parser. I'll reload that. We'll get, yeah, room. Get read W. We'll run our parse test. Another dimension, line 15. Okay, so we got a parse error on that. World.text. Oh, we forgot to put a number on this one. Yeah, so that should be fixed there. Do that again. And there we go. So now it's parsing the room entity IDs into our map. Perfect. Okay. Now when we run exec on this thing, we should get a perfectly fine game.exec. Let's see, this one. What happened to our world.text? Oh, wrong directory, sorry. Badoo. Now that should work. So then we jump over there. What's in data, example, adventure. Let's get rid of that. That was an accident. Yeah, and so the entity IDs are proper there. So let's just, yeah, 1, so on and so forth. Okay. Cool. Let us commit that. Room entity IDs to parser. Sweet. Okay, so now we can add rooms, well, basic rooms and the entity IDs. We should fill out more of the, and we can generate the zip file too. So we should just add more of the fields that you should be able to define in our input format. What do we want to tackle next? Pull up our example file that we want to parse, our parser. All right, so we need to be able to fill in more of these objects, exits. That's going to require object parser and exit parser. The world player room. Let's see, a section parser would be like a list of things. Maybe we could have like a special section. How would we define that one? Maybe something top level like this. That looks pretty reasonable, maybe. Basically, we would write a parser that would consume this variable first out of the file. Oh, wait, sorry. Before we get to that, we have one more requirement for the room parser. That's right, before we can mark it done. It would be a parser to define duplicate entity IDs for the rooms. We need to fix that first. Okay, so how do we do that? Well, we can either keep some state with us, potentially, while we're parsing, if that's possible, with megaparsec. Or we can validate this after we finish parsing the world rooms, before we construct the world object. Which is probably the easiest thing to do. All right, so if world rooms is invalid, we should throw a parse error, basically. Validate rooms. We'll just undefine it here and see if GHC will tell us. No, we actually do want to be able to throw something here. So it's not necessarily over the list. That's better. Yeah, this is the type I want. For validate rooms, it should be a parser action. So it should end in a parsec t of some kind, or parser. This looks oddly familiar. Really a parser of list entity ID room to room. And that should be the type. Okay. How do we find if there's duplicate entity ID of rooms? That's all we really care about. I think we call this rooms. Okay. Let's do. Well, we we could take the set of entity IDs of room entity IDs. Let's convert this list of the first elements into sets. And if it has the same length as the input set, that would mean that there are no duplicates. There might be something in data.list for that. Or not. I think it's nub. Not the most performant. So hopefully you don't have like a large n, but for a fairly small n, this isn't too bad. So we could say room IDs give me the first elements of rooms. And actually, maybe we could do this with a guard. We're gonna need data.list. So where nub of the map first runes, and the length of that is the same as the length of just rooms. We're good. Otherwise, we got to raise some kind of parse error. Having a fun time with that. Okay, megaparsec. Let's throw an error. No, not exactly. Parse error builder. I want an easy way to construct one. I don't really need a custom way of doing it. Signaling parse errors. There we go. Failure fancy. Hmm. Fancy failure. Error fancy. Mm-hmm. Very, very interesting stuff that it's giving you to do a lot of stuff. Printing fancy errors, which is great. I just want something super, super simple. I don't even know how to construct an error item at this point. Or fancy error components. Or trivial parse error. I'm going to need data.set. That's something to satisfy that. Import as S, kind of follow my convention there. How do I make an error item? Tokens, label, or end of input. Oh, error fancy, I can just use error fail. Let's do that. Error fail, fancy failure. Error fail. Cool. Error fail. Enter room IDs must be unique. Okay, and then in the happy case, we just return rooms. And that should work for that. So if we go to world.text and we enter a duplicate and we try this, we should get an error here. So we don't have the proper error reporting on like where in the text file it is, but it does report that the rubies must be unique. There's a cool way to figure out all of that extra metadata, that would be super. What if I just... What if we don't do fancy failure, but we just do fail? Will that give us a better error message? It still won't. Probably because we're validating after we've consumed all the input. Hmm. I mean, that works, but that's not a nice output for the author to see. Hmm. So we might have to go for the section, like implementing parse state with the parser in order to get this down to the line where the failure occurs. Okay. Let's back out of this then and try that. I think we got enough time to try that, go down that route. Yeah, let's do that. Okay, so instead of validating them down the road, we're going to have to pass the state through. Now, I don't want to make too much of a change here, but I think one way we could attack this is we could thread the state through the arguments. All right, we could make room parser take um, a set of entity IDs of rooms that we've seen. As a parameter. And we'll need to import data.set and all that stuff. Import data.set, the type, and we'll probably need functions from that, so we'll import those qualified. Data.set as s. And now, when we pass room parser to section parser, we have to give it something. The empty set initially. Now we don't use scene IDs at all. in room parser. But we do parse one. Which isn't going to quite work. Because we have no way, if a room parser here by itself doesn't call itself recursively, that's up to section parser here. And section parser doesn't know that we have any state here to pass through to the P parser. So that doesn't quite work. And what else? If we make section parser take a to be responsible for this, so we put the duty on section parser to say, well, now you have the requirement that every element in your that you're going to parse out from P, every P that you parse, also has to have this entity ID in it. And then you can pass around the state that way. So then the P just has the responsibility to return back, yeah, the entity ID that it parsed and the room in a tuple of somehow, those two things. And then the section parser can build up the state passing to the next P. Except the sep end by P. So we might need our own combinator that has the state in it. Or our own parser. Parsec does inspect the transformer. Parsec T. So the handy thing about exposing parsec T like this is that we could make we could stack a state, right? Put a state in here. I guess we would put the state inside the parsec T. As the underlying monad. And then we could lift our state operations up into our parser to get access to the room IDs we've generated so far. That could be useful. So let's try that approach. Back out of this as well. A parsec is probably just a type alias over the identity monad. We're going to do a parsec t. Let's see, sorry, not parsec void. We'll do parsec t, where E and S, still those. And instead of identity, we'll do state. And that will be something I don't know yet, like just call it adventure parse state, maker parse state. Sure, maker parse state. And entity, we have one, a set for room entity IDs. That will be an equal sign, and that will be type. Import data.set. And because I know we'll probably need it, data.set qualified as S. Okay, and then left is state T. Not the class. But the transformer. And then we'll do that as state T of maker parse state, and M will keep as identity. So we get that from controlled monad.state. And identity. Why is identity not in scope? Oh, that's fine. Okay, fine. You want to make it a new type for now? That's fine. And I know it's redundant, but it won't be redundant for long, probably. Okay, so we remove that. Those should all work still. And now, this is feeling better. And now we can actually get the room ID. We can lift the state and get maker parse state and the entity room IDs. And we need record wildcards. Language, record wildcards. Nothing is bound yet, and that's fine, because once we parse the room ID, we can then do the check here, the validation. We can check if the room ID that we've just parsed is element of world room IDs, room entity IDs. And then something else, something else. Or, what else could we do? We do when room ID is an element of room entity IDs. Should say scene. Room entity IDs. What's not s.elem? Oh, data.set. Come on. What is it? Member? Member. Okay. So if the room is a member, why isn't that working? Oh, room ID. Sorry. If the room ID is a member of scene room entity IDs. Okay. Then we can just fail here. Room IDs must be unique. And then we just have one more problem. Where is that problem? It's not in this one. Maker. Right. The running function to actually run our parser is a bit different now. So we need to use our run parser, run maker parser, which takes a actually don't know what the type of that be. We have to run the state monad along with the parser. With the initial state. So I'll leave that undefined. Let's run maker parser as a silly type. Let's update maker.hs to run maker parser. Hmm. Okay. Yeah, I guess that makes sense. Something like that would be the type. A little too specific, but we're going to fix that up. It's going to change this to A. The return type will be A. So we need a left or right. We need either. Whatever the return type of run parser will be. Run parser. I guess that kind of works. Almost, but not quite. Mm, yeah, okay, let's try. I'm going to try this approach here. Running a little low on time. I'm just getting a little tired here. But run maker parser, basically we want to run the state monad and then run the parser. I think that's how it goes first, right? Because we're going to parser of A. And we wanted, oh yeah, we want to return an either. Parse error bundle. SE or A. Okay, so then to run the state, let's leave that undefined right now. That's state T SMA, takes an S, and gets an MAS. Then we want eval. It just returns the MA. So we're going to use eval state T. or just eval state. Eval state t, and that takes the initial state. It takes the state t SMA, an initial state, returns the MA. Maker parse state s dot empty. And so we get the first of the parser A, so we have to peel off the parser A in order to run the eval state computation. Right. Run parser. If we go to maker, where are we actually using that? Takes the parser, but also these two arguments that are really run to run parser, arguments to run parser. So I'm going to add those in as well. File path and text. And then we'll run the parser p s apply to e, something like that. Okay, type error here. We need to run it. We also, then we get an identity as the base monad. Mm-hmm. Okay. I just got those flipped around. Okay, string. Okay, what am I? Run parser T. What am I looking at here? Parser, which we have, the string and S. S is the input, string is the name of the source file. So that could be file path. That could be the input for the parser. Okay. So let's get rid of that. Call it fpath. Fpath. That's fpath. Some S. Okay. Now we have to pass P in. Let's go on here. We have a expected type state T, maker parse state identity. Parser T is applied to too few arguments. On parser T is the P is given. Parsec T, yeah. String, which is our fpath, yeah. Oh, okay, that's probably what it is. It's trying to switch to a point-free definition. So could match type S with text. I think we did fix that, didn't we? Okay, there we go. Now we have run maker parser. Our problem here should not be there. That might just be, yeah, that just might be stack not kind of restarting there inside my editor. But that should work now. Except, it doesn't look like it is. Let's see. Let's remove gate.zip as well. Just double check. Oh, right. It's not working because we're not updating scene rune entity IDs. So in the case where it's not, this when condition isn't hit, then we can lift and we can put maker parse state where where the scene room entity IDs equals s dot add room ID added to the scene room entity IDs. Oh, it's not add, it's insert or something, isn't it? Okay. Okay, so that builds world.txt. We have a duplicate number now in our source file. Now I'm kind of expecting that when we run this from the right directory and everything, that we should get a parse error. There we go. On line 15, number 1, room IDs must be unique. 15, number 1, right here, room IDs must be unique. Boom, we did it. And that, my friends, is why transformers are pretty useful. And why, if you're writing a library, you might want to expose your central monad as a transformer so that people can extend it with new functionality as they need it. Very, very handy. Okay, that was the much better way to do that. Cool. So yeah, I guess the first approach I tried there was the simplest, dumbest thing I could possibly think, which is passing the state through as a function parameter, but obviously found that wouldn't work with the way the combinators are structured in our library here. And the better approach is to just redefine the monad, the parser monad being used, monad, I don't know. I'm going to use them interchangeably. And to have new behavior by using the parsec t. And so when we do that, we have to write our own runner function to evaluate all the different layers of our stack there, but that lets us add behavior to our parser, like being able to check for duplicate parser IDs by keeping the state around about which IDs we've parsed so far. And so we can just get those out and put them back and do all the state manipulation stuff there. So now the room parser is a stateful parser, and that can be pretty handy. But we didn't have to really manipulate, we didn't have to change anything about section parser itself or the world parser as a whole. Pretty useful, I would say. It's quite nice. So let's get that committed. Although let's remove that from the examples just to, that was just for our own testing purposes. So stage that, just quick little review, make sure we don't have to refactor anything. Looking pretty solid. Okay. See, add maker parse state to parser. added a state t to the parser t stack so that we can raise parse errors when the room entity IDs in the source file are not unique. Sweet. Okay, let's push those up. And there you have it, folks. That's the stream for this week. If you're just tuning in for the first time and you're on Twitch, then you know you can click the subscribe or the follow there to follow this channel and get notifications and whatever when I start streaming. See my schedule and all that. I usually do these on Tuesday evenings in the Eastern Standard Time Zone, so if you don't want to follow, and you can write that down and show up when you feel like and, you know, follow along. On this channel, that's what I do. I build practical Haskell applications in a kind of a using sort of real-world-ish type programming styles that I would use on the job, just so that people can see what it's like to work with Haskell. And sometimes we just mess around and have fun. So if there's any ideas for projects you'd like to see or things you'd like to learn, just let me know. Join the Discord by following that link up above. We have a channel there for just the stream, as well as channels for every other streamer out there doing cool functional programming stuff or in various declarative languages. And you can also follow me on the socials, on Twitter, GitHub, elsewhere. The code available for this project is on GitHub at Agent Ultra. That's me. And the project is Adventure Engine. So that's all here. Probably should protect this branch, maybe. I don't know. But there you go. Fork, PR, whatever, away. And have fun. So may all your monas be free. May your types always check. And hopefully I'll see you next week. Take it easy. Have a good one.